Hi, grade 10s. This is our second lesson for today. We have 3 lessons today. So we're going to be looking at heat transfer. So you should have your notes in front of you so you can be writing down information. The first definition I wanted to mention is this term called albedo. This helps to regulate temperatures on Earth. So basically, it's just the percent of incoming solar radiation that a surface reflects. So the more that it reflects, the less it absorbs, obviously, and so the cooler it would be. Okay, so the albedo of the entire planet is about 30%. So light-colored surfaces, those would be things like snow and sand, would reflect about 90% of the incoming radiation, and then duller surfaces would reflect about 10%, meaning that they absorb 90%. And again, this changes the season because obviously in Canada we would get snow in the winter, and that would increase our albedo. Okay, so now we'll talk about the heat transfer. So heat transfer is basically the movement of thermal energy from an area of high temperature to an area of low temperature. That's what we usually tend to focus on. So it goes from hot to cold. Okay, so thermal energy transfer can occur by radiation, conduction, or convection. Sorry. So we're going to start with a quick kind of definition of each of those 3. So conduction is the transfer of heat energy through a solid. So again, it starts with the cooler particles that are gaining temperature. So the hot particles transfer to the colder. So basically it occurs in solids, like you can see here. So the particles collide and vibrate, which transfers the energy. Okay, then we have convection, which is the transfer of heat through a moving liquid or gas. So it occurs when particles with lots of heat energy in liquid or gas move and take the place of particles with less heat energy. So you've heard before that, hot air rises. So this is because the hot air has a lower density and it can rise up, and it will push down the colder air with a lower density towards the ground. Okay, so particles in a liquid and gas can move and transfer heat. In a solid, they're not able to do that. And then the last one is radiation. So radiation is electromagnetic radiation emitted from a hot object. So for example, the sun, it's invisible and it's felt as heat. So the hotter the object, the more radiation it emits, and it travels in waves. So the other 2 travel using particles. This one travels using waves. So there's a quick practice that I want you to complete. This isn't printed on the handout, but you can just write it into your book. So there's a Venn diagram summarizing the 3 forms of heat transfer with a space in the middle for things that are common between all 3. Okay, so there's some answers here. So conduction, talking about solids, convection, liquids and gases, electromagnetic radiation, and so on. The fact that all of them transfer heat energy from hot to cold. Okay, so now we'll talk about how heat transfers in the atmosphere before we talk about the hydrosphere. So different parts of the Earth receive different amounts of insolation from the sun, so the heat transfers throughout the atmosphere. So the temperature will increase near the equator, so it's a lot hotter there. And we know that warmer air exerts less pressure because it's less dense, like I talked about with convection. And then the last thing is talking about wind. So this is just the movement of air from a high pressure to a low pressure area. So something that occurs in the atmosphere is what we call the Coriolis effect. So this is the deflection of any object from a straight line path by the rotation of the Earth. So it causes moving air or wind to turn right in the northern hemisphere and to the left in the southern hemisphere. So it also causes the winds in the northern hemisphere to circulate clockwise, and then winds in the southern hemisphere circulate counterclockwise. Okay, another effect in the atmosphere is just global wind patterns. So convection currents in the atmosphere and the Coriolis effect result in the global wind patterns. So they transfer thermal energy from areas of surplus radiation, meaning loss of radiation, to areas with a deficit radiation, meaning less. So near the equator, the warm rising air causes higher altitude winds that flow towards the poles, so north or south pole. Okay, so to replace the rising air, the cooler surface area moves towards the equator from the higher latitudes closer to the poles, and that's called the trade winds because it's trading. The warm air is going to the poles, the cold air is coming from the poles back to the equator. Okay, and then the last effect in the atmosphere is what we call a jet stream. So basically, this is caused by the presence of continents or large bodies of water, and it will also affect the wind patterns. So the definition for a jet stream is a band of fast-moving air in the stratosphere, which is a layer of the atmosphere. So these winds are at a high altitude, so they're higher off of the surface, and they're subject to very little friction. So they're a lot more fast because they're not being slowed down by friction. So changes in the jet streams affect the formation of severe weather events like squalls, storms, and cyclones. So that can cause issues just because of those high-speed winds. Okay, so there's a quick quiz here. I just want you to match the term to the correct definition. So you can pause the video and take a couple minutes to do that. Okay, so we know the Coriolis effect is the deflections. Wind patterns transfer thermal energy from areas of surplus to deficit. And then the last one, the jet stream, we know is a band of fast-moving air in the atmosphere, specifically in the stratosphere. Okay, and then we have heat transfer in the hydrosphere. So we know already that water covers about 70% of the Earth's surface and has a very significant effect on the transfer of heat. So water changes phases, meaning it goes from, a solid to a liquid to a gas and so on throughout the water cycle. So each time that water changes phase, it either absorbs or emits thermal energy, heat energy. So this helps keep the average temperature of the Earth relatively stable over time. Okay, so we're going to talk specifically about heat transfer in oceans. Obviously, these make up a huge proportion of our Earth. So ocean currents are the main pathways for transfer of thermal energy from warmer latitudes near the equator to cooler areas near the poles. This is how we get the movement of heat. So the global winds blow on the ocean surface, and that causes currents, so surface currents. And then ocean currents move warmer water towards the poles, and then colder water moves to the equator. And we know from convection that colder water is more dense and will sink, and the warmer water is less dense and will rise. Okay, so obviously global warming is having a big impact on this because it's causing an overall heating of the oceans, and that's affecting the transfer of heat to the different areas. Okay, so that's the end of this video. There's a handout to complete where you might have to find more information online to complete your definitions that are on the page, and you will also need to draw an image to represent that definition. Again, I haven't shown you those in this video, so you'll need to find those online. If you don't have the sheet printed in front of you, you can just write those in your book with the notes for this.